Now that we understand what a logarithm is, we can actually learn a couple of properties that are going to help us solve logarithmic equations. Just like every other equation we've solved, our goal is to get x by itself. However, in a logarithmic equation, that's pretty complicated. Not only do we have multiple x's, we have the word log with a base listed here. There's a lot to do. So the first thing we need to know is how do we consolidate these logarithms? And that's where these properties above come in handy. The first one is the product property of logarithms. The product property says that if you have two logs with the same base added together, the rule is you can take these quantities and multiply them. You can take this 5 and this 6 and multiply them and simply write the log base 2 one time, and then 5 times 6 makes 30. The log base 2 of 5 plus the log base 2 of 6 equals the log base 2 of 30. When you're adding logs with the same base, you simply multiply these components. The quotient property is next. Quotient property of logarithms. This states that if you have two logarithms that are subtracted, you can simply divide these components. So when we are going and subtracting logarithms, that means you divide these components in the order that you see them. 5 is the numerator, 6 is the denominator. And then finally, we have our power property of logarithms. That means that if you have a coefficient out front before the log, you can move that to become an exponent within the logarithm. So a 5 as a coefficient can also be the exponent of this quantity. These are things that are going to help us consolidate and eventually eliminate the logarithm portions of our equations and make them manageable to solve. So the first example, we have an addition symbol in between two logs that are identical. We have the log with identical bases, log base 6, log base 6. So the rule is when we're adding, we can write it one time and simply multiply these components. They're going to multiply. So x times x minus 9 equals 2. Now we need to get rid of the log. We can also simplify further right here because we can distribute the x. X squared minus 9x equals 2. In order to get rid of the log, that's when I want you to think back to what we learned in our last video, where we can rewrite it in exponential form. We can say 6 to the second power equals x squared minus 9x. It's looking better already, right? Now we have our x's on one side. We've eliminated the word log. Now we just have a quadratic function. 6 squared is just 36. And when we want to solve a quadratic function, we need to have it set equal to 0. So I need to subtract 36 from both sides. So I have 0 equals x squared minus 9x minus 36. We can solve quadratics with a variety of methods. This one is easily solved by simply factoring, by saying what multiplies to give me negative 36 and adds to give me -9, or combines. 1 and -36, 2 and -18, 3 and -12, 4 and -9, 6 and -6. Do any of these combine to give me -9? And the answer is yes, 3 and -12. So that's what I'm going to put into my factors. X plus 3, x minus 12. When I have two factors multiplied together equal to 0, that means either x plus 3 equals 0 or x minus 12 equals 0. Solving by subtracting 3 from both sides, I get x equals -3, or adding 12 to both sides, x equals 12. Now we need to go back and check both of these solutions in our original equation. Now because sometimes you can pick up an extraneous solution when you're solving logarithmic functions, you need to make sure to test both of these solutions back in our original problem. So let's take x equals 12, our positive solution, and go back to our original equation. The log base 6 of 12 plus the log base 6 of 12 take away 9, that's 3. Does that equal 2? Well, combining our logarithms with the multiplication, we get the log base 6 of 36 equals 2. And using the exponential form, 6 squared, does that equal 36? 6 to the second power, is it 36? And the answer is yes. So x does equal 12. Let's take a look at what happens when we try to put in our other solution. Log base 6 of -3 plus the log base 6 of -3 minus 9 is -12. Does that equal 2? Well, our first problem comes in right here. This is some number. We don't know what it is, but it's a number. Log base 6 of -3 is some number. We'll call it y. 6 to the y equals -3. Is that possible? Is it possible to raise 6 to any power and get a negative number? It is not. That is not possible. We cannot have a logarithm with a negative quantity right here, or right here for that matter. So -3 is an extraneous solution. And it is not a solution. Now be careful. Don't just assume that if you get a negative answer you can throw it away, because sometimes when you substitute it back in, there'll be other numbers with it. Maybe this was a +9, and when I put a -3 in here, this whole quantity becomes 6. So don't just throw all the negative answers out, but make sure to check them. Let's try this next one. Again, we're trying to get x by itself, but the first thing we need to do is, take this 2 and make it the exponent of the x variable on the left side. So we have log base 7 of x squared. On the right side, we have the addition symbol, which means we can multiply these quantities. We end up with the log base 7 81. Now the rule is when you have two logarithms, one on each side, and no coefficients, and they have the same base, the log base 7 of this quantity equals the log base 7 of this quantity. They have the same base, so these need to also be the same. So going to the next line, I can just drop the log and the base and write this. I can take the square root of both sides, and I get x equals plus or minus 9. Now, thinking back to what we just learned in this original problem, 2 times the log base 7 of negative 9 is not possible. I'm not allowed to have a negative number by itself right here. So that means that I can eliminate that answer choice, and my final answer is x equals 9. Moving on to our last example. Again, we have addition, which means we can multiply these two quantities. We write one logarithm, and then we multiply their two quantities. I can use my exponential function notation conversion, which means 6 to the second equals x times x plus 5. Distributing the x squared plus 5x. Simplifying on the left, I get 36. Setting it equal to 0 by subtracting 36 on both sides. Now we're thinking, what multiplies to give negative 36 and positive 5? And here we have our winning combination, negative 4 and 5. So solving by factoring, x minus 4 times x plus 9 gives me this trinomial. And solving each piece, x equals 4 or x equals negative 9. Again, putting a negative 9 right here in our expression is not going to work. I can't have the log base 6 of negative 9. So I'm going to eliminate that answer choice. And I'm going to look strictly at this one to check it. Log base 6 of 4 plus the log base 6 of 9, does that equal 2? Expressing it as one logarithm and changing to exponential form, 6 squared does equal 36. So this answer choice is valid.